Hi, today we're going to talk about machine learning algorithms. And our outline is as follows. We'll have an introduction, definition, learning problem, types of machine learning algorithms, machine learning workflow, applications of machine learning. On the introduction, we have this thought. Ever since computers were invented, we have wondered whether they might be made to learn. Now, learning is one of the key components of computers nowadays, and we really want to understand what does it mean to learn. Now, imagine, for example, computers learning from medical records which treatments are most effective for new diseases. That means that computers would be able to give you or advise you or consult with you based on what information you give it, and then it can be able to give you the best treatment for a new disease. Or think about how this learning from experiences to optimize energy costs based on the particular usage pattern of their occupants. Houses become so smart to the point that they give the optimum uh, service, let's say when it comes to energy or something else. But is it possible for these houses to learn on better operational procedures or levels? And then finally, you have a personal software assistant learning the evolving interests of their user in order to highlight especially relevant stories from the online morning newspaper. This means that people are able to customize or to get or to receive customized news or information. And this means that there is a possibility of us having personalized or optimized or better and effective uh, services from what we now call them as computers. And this is possible by having this computer learn various patterns and see whether they can be able to improve upon what they have learned. So that is what we call as machine learning. Let's have some few definitions come through. Now, machine learning is building machines that can adapt and learn from experience without being explicitly programmed. This means that we are able to program machines or computers to learn and to keep on learning, meaning that not being explicitly programmed means that it's not going to be a static program. It means that it's going to increase knowledge based on the data that it will be receiving from time to time. And we have another definition here that excuse me, that says that the field of study known as machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. So it's now becoming clear that these computers are able to learn through computer programs. And these computer programs are supposed to automatically improve with experience. That means that the more the time it has to work with data or really understand what data is, then it should be able to improve on its experience. Then finally, we have another definition of machine learning, which says that a computer program which learns from experience is called a machine learning program, or simply a learning program. Such a program is sometimes also referred to as a learner. Now, this is what we are going to study, or to say this semester or in this course, whereby this program or machine learning program, uh, how it learns from experience, or how it builds upon experience, or how it builds upon the information that it has already gathered. So generally, machine learning is all about building systems which would uh, give better services based on the experience that they have had with the data that they keep on getting or receiving. Now, we want to talk about the learning problem. Now, we need to visualize learning and understand how computer really understand learning. Now, a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P. So we have three important aspects here. It's about experience, it's about tasks, it's about measure. Then it keeps on saying that if its performance at tasks in T as measured by P improves with experience E, meaning that then it's possible for this computer to improve upon uh, yeah, its tasks that it's been assigned to do, and that improvement uh, can be equated to experience, and this can be measured to really see whether this experience or this improvement is positive or negative, or good or bad. And that's why we are saying here that to have a well-defined learning program or problem, three features need to be identified: the class of tasks, the measure of performance to be improved, and the source of experience. So this is very important for any machine learning. Now, number one, we need to understand that tasks are the activities that the machine is going to perform. It can either be the work of, if it's in a self-driving car, trying to see if it can drive itself safely through the road. And the measure of performance is to see that there are no accidents. How is it performing? Is it making any error, or is it not making any error? So that is a measure of performance that needs to be measured. And then the source of experience, it can be having some data about that road or about driving and etc. So all this information are very important. So tasks need to be defined, and then the sources of experience, let's say it's data, needs to be defined or supplied, and then finally the measure of performance to be improved should be measured or should be identified. So we need to find out what is really happening here. Now, for example, we have a checkers game. We sometimes call it craft. I don't know what other names are given to it. But nowadays, we know that computers are able to play this game with other users, or even among itself or with itself. So, for example, Computer program that learns to play checkers might improve its performance as measured by its ability to win at a class of tasks involving playing checkers games through experience obtained by playing games against itself. For example, the task is to play a game, and then maybe already the instructions that have been given on the rules of the game, the correct procedure to play the correct move and the incorrect move. So with time, the computer would start learning that these are valid moves, these are invalid moves, and then these are right moves, these are wrong moves. And then with time, it would know that with such a move under a particular circumstance, there is a high probability of winning. So through more and more experience or more and more games, let's say the computer playing game itself, it will gather more experience and then it would know better routes or better paths or better patterns of playing a winning game or having a high probability of winning. That's why we are saying that a computer that learns to play checkers might improve its performance as measured by its ability to win. So the more it wins, the more its performance keeps on going high and high. That's how we can measure that. Again, we can now see this one clearly that the tasks here is playing checkers, and the performance measure P is the percent of games won against the opponent, and then finally the experiencer is playing practice against itself. Now, a robot also, on the other hand, the task might be driving on highways using vision sensors, and then the performance measure is the average distance traveled before an error. Then finally, training experience or E is a sequence of images and steering commands recorded while observing a human driver. That data was already fed. So based upon that data, we get that this machine is learning. So ideally, what we need to really have clearly is this, that for any machine to learn, there has to be tasks. And apart from tasks, there has to be data or information or where we're going to get the training experience from. And then apart from that, we are going to measure the performance, whether we're improving or whether we are not improving. And by so, if we keep on improving upon that, then we can state uh, affirm, we can affirmly, we can say that without any fear of contradiction that this machine is learning. Therefore, in machine learning, there is the following things. A learning algorithm. So this algorithm is one that keeps on learning. And the number two, we have data. This is the data that is fed into the computer or this machine. Then it helps it to learn or to improve its knowledge. And this data, in many cases, we call it as a training data, which is fed into the learning algorithms. And then the learning algorithms will draw inferences from the training data set. So it will start inferring that because of this is this, because of that would result in something like that. So it will begin to infer, and then with time we'll get a model generated, uh, which is a function that maps input to the output. So this ideally is now the few components of machine learning. Now we have various types of machine learning algorithms. and they can be divided into three major types. One is supervised learning, secondly is unsupervised learning, and thirdly is reinforcement learning. Now, what about each one of these? For example, supervised learning is learning using labels. So you get that the information being fed into this computer has got labels. So the computer or the machine is able to use the labels as a guide, whether or as a, as as experience or as information which is very true or correct. So it means that this supervised learning would always have information that is labeled, and based on that information, it can be able to predict more information later on. And unsupervised learning, it's all about having information that is not labeled, and the computer is supposed to somehow discover either patterns or some behaviors or some characteristics which are unique there. So no guide or no label. Then finally we have the reinforcement learning, whereby this machine or computer learns by being reinforced, or let me say this, as time goes by and by, there's something like a feedback or loop that keeps on rewarding uh, the agent or the machine, so that if the machine, for example, makes a good or a right move, yes, it's given a reward, and then it knows that it's doing well, and then it keeps on improving upon that. So that is like you're reinforcing the learning. So it's very important. We can see that one, for example, through this diagram here, whereby we, for example, have got pictures of dogs and cats, which are fed into our machine learning algorithm. The good thing is that these pictures have got captions or labels. So if for example, it's a cat, the picture is labeled as a cat. If it's a dog, it's labeled as a dog. And then these are fed into the machine learning algorithm. The good thing is that when data is being fed into the algorithm, it has to be processed, and then features must or are going to be extracted. Now, this is where we're going to get these labels extracted, and then the machine learning algorithm will be able to learn what features each, for example, each photo or image is trying to represent, and based on that, it could be able to test future images and predict uh, a label, whether it's a cat or a dog. So, based on the labels, we can have a machine learning algorithm test and know that there is uh, uh, a place where we are supposed to have what? We're supposed to have a new document or a new image there classified. Or, yes, number two, we also have unsupervised learning. This is whereby we just have got pictures without the labels. So it's the machine learning algorithm that is going to now discover and see what are these characteristics that are in these pictures and then or images, and then using the algorithm, it is able to cluster, for example, cats together and dogs together. So without any labels. So it's very important for us to understand that unsupervised don't have any labels, while supervised we have got labels. Now, Reinforcement, as I have just already stated, is that it works in this uh, format. Let's say, for example, we have an agent state and we have an environment state. We can just talk about the environment being either a computer system or something like that. Now, this agent state is programmed to always operate in a particular way, but based on the characteristics of the environment, this agent would keep on giving or providing some action. And these actions, of course, if they are observed as okay or good, they keep on doing what they keep on giving a feedback loop of something like a reward back to the agent. So the machine keeps on learning and observing what is happening. So actions and observations are very important because they will always affect the state of the environment. So we can state here that there is supervision, though not explicitly, but rather implicit, because the feedback, it's like it's trying to supervise. The feedback that is there is a form of supervision. Now, supervised learning is used often, and a good example is shown here. This supervised learning learn a line or a curve using training data consisting of input-output pairs. Use it to predict the outputs of new test inputs. Now, it's possible for us to have data, and once we present this data on, for example, a scatter chart, then we can be able to see that it can form something close to a line. And then you can draw the best fitting line there, and based on that line, we can be able now to predict any value, something like a continuous data can be used to or can be predicted on a regression. So that is supervised because it is assumed that for every input there was also an output. So that is what happens in regression. And in classifications, for example, when it's supervised, we can have various types of classifications. Either it can be a binary classification or a multi-class classification, or a multi-class nonlinear, or two-class binary nonlinear classification. There's so many ways in which we can see this classification problem. Now, what happens is that it's possible to learn a linear or nonlinear separator using a training data consisting of input or output pairs. So it means that each output is discrete value label or the corresponding input. It means this way that we are going to predict whether a label is going to fall on one side, the right side, or the other side. So we have classes. So this is discrete, which means that you're predicting a state or a label. So if you have two classes, you might be either in class A or B. So people are going to predict whether you're in class A or B. So that's what is happening. Or you can have many other classes. So this can happen still with supervised learning. Now, This can also be done with unsupervised learning, whereby data is given out and then this data we can find characteristics there and we can have clusters coming through and then you can go to see how this data had more characteristics which maybe were latent. So it's very important to know that we can learn the grouping structure for a given set of unlabeled inputs. So there are no labels, but then the machine learning algorithm will ensure that this information is already classified or is clustered in a dashboard. Now, we need to understand then machine learning is very important and it has got a workflow. Workflow is generally what you would go through for you to run a successful machine learning algorithm. One of the things is that you need to know and have the source of your data and prepare your data very well. So many processes are used for that. Then you need to code your model. Then after that, you need to train, evaluate, and tune your model. And then once that's done, you can deploy and then you can start predicting. And then finally, you can monitor what's happening with it. And then you can manage it. So that's basically the steps for or that one would go through when you're trying to run a successful machine learning algorithm. Now, the applications they can not be exhausted here, but then we know that it can be used on the internet. Emails, for example, spam and good messages. It can also be used in recommendation systems, recommendation self-driving car, you can use the medical line in predicting that is always done when it comes to forex money markets. Then it can be used for security, for fraud detection, and many other cases as we can see here. You, for example, can use machine learning to learn to generate captions for images. Sooner or later, you will be able to understand that we can generate uh, captions for images. For example, they can be a picture can be presented to machine learning algorithms, and then the question can be posed that what is happening with the picture. If people, for example, playing football or if they're eating, it, it's possible for the computer to do what? To generate that caption to that image. So to summarize texts, for example, you might be having very a lot of information to read, but you don't have that time. You can have it summarized in point form, and machine learning can be used to do that. And then we need also to understand that it can also be able to identify topics within there, translate text, speech, and many other things. This is what we need to understand. But all these things would always come by first having the computer define a task and then also have a performance measure and then also keep on improving on this experience by having the right data. So that is briefly what machine learning is all about. And in the following classes, we will start dissecting and handling some of these machine learning algorithms one by one and see how we can get the data, how we can build the models, and how the models can be trained, and how to keep on uh, improving on the experience. And then finally, we can also see whether the performance is good or bad by evaluating these algorithms. So that is majorly what machine learning algorithms are going to do for us. Many other things that machine learning algorithms can do, We'll discuss them in class many other places. Otherwise, see you in the next lecture of supervised machine learning. Thank you.